All right, so on number 8, we have 2 to the x equals 17. Can you get like bases? No, there's nothing to do. So if you can't get like bases, what you can do is, because look, where is your x at? It's in the exponent. So we need some way to get the x out of the exponent. And if we can't get like bases, the only other way to get x out of the exponent is if I can bungee it. And what did we use the bungeeing with? The logs, right? So remember, the rules of equality says what you do to one side, you have to do to the other, correct? So if I'm going to log the left side, it's okay as long as I log the right side. Now when I do that, what can I do with that x now? Yeah, I can bungee in front of its log. So we have x log of 2 equals log of 17. And if I want to solve for x, what's going on? What mathematical operation is it going on between x and log 2? So if I want to get rid of the log 2, how? What would I do? Divide. And what are we trying to get rid of? Log 2. And so we have there x equals log 17 divided by log of 2. And it told us we could use our calculator and to round it to 2 decimal places, correct?
Did we do this in algebra 2?
Yes.
I remember doing this.
Good. So that means you had to do all the other stuff to get to this point.
Yeah.
All right, so what'd you get? What is log of 17 divided by log of 2? All right, 4.09. Now, what did I do wrong? I did something wrong. What was it? I didn't follow directions. My answer is still going to be okay, but I didn't follow directions because it said to use natural logs, didn't it? So what it was really looking for me to write there was, I'm just going to start at the beginning. It wanted me to write the natural log of 2 to the x equals a natural log of 17. But our steps are exactly the same, okay?
So is it a different answer?
No, it's going to be the same answer. I just didn't follow directions.
So why does it matter if you use natural log? Why is there even natural log if it's the same answer?
Well, because...
Sorry, I'm just confused.
Yeah, it doesn't matter. I could take log base 2 of 17 over log base 2 of 2, and I'm going to get the same answer at the end, okay? Or log base 5 for both of them. It's going to be the same answer in the end because I'm starting with the same problem. It's just 2 different ways to work it. The reason I really should have used the natural logarithm here is because it told me to, and I should follow the directions.
Like, why would it tell you to do that? Like, even though, like, either way...
Honestly, it's a personal preference. Honestly, it's just a personal preference or whichever one you prefer to use.
That's so weird.
Now, sometimes you'll use specific ones because, like, I could have used log base 2, and using some of my rules from the first lesson that we did on logarithms, I could have been able to simplify this a lot quicker. But I'd end up with the same answer at the end. So, everybody okay, though, with it? Same answer, just 2 different ways to do it, but I should use the natural logs because that's what the directions told me to. So let's look at number 9. What's different on number 9 that we haven't seen on the others? Well, we've seen it with e, but we haven't seen it with the exponential piece, so that e to the 7x with a number in front, have we?
No.
So that's the first thing we need to do, is we got to get rid of that number that's in front of that exponential.
Natural log.
Well, in a minute we will, but right now we got to get rid of the 4. So divide by the 4. Before you can do anything else, whether it's get like bases or take the log of both sides, you have to make sure it's only the exponential piece by itself, and we hadn't seen that yet. So we had to get rid of that 4. So we know e to the 7x equals, what'd you get?
2,568.
Okay. Now that we get the exponential part by itself, can we get like bases? No. So we're going to natural log, because that's what the directions told us to, right? And so we're going to natural log both sides. So the natural log of e to the 7x equals the natural log of 2,568.25? And so let's take that exponent now and budgie it in front of its log. So 7x natural log of e equals the natural log of 2,568.25. Now, do you remember what the natural log of e is equal to? I don't think we talked about it this year. You should have covered it last year. Let's think about that. This is one of them that I just memorized. So if I got the natural log of e, it's in log form, so we'd set it equal to y if we're trying to solve it, correct? So what is the base on a natural log? E. And so when I set it up into exponential, this is my b, this is my x, and that's obviously my y. So I would do b to the y equals x. What is the exponent on that second e over there? A 1. And so what is y equal to? So what is the natural log of e equal to? 1. Natural log of e is always equal to 1. So don't really need it there, because what's 7x times 1? 7x. So from here we know that 7x equals the natural log of 2,568.25. Divide by the 7. And so x is approximately, rounded to 2 decimal places. Good. You did. All right.